Good morning, everyone. Myself, Dr.C.Mariyal, Associate Professor, Department of Electronics and Communication Engineering, PSN College of Engineering and Technology. Today, I am going to take a subject about digital image processing. Introduction of digital image processing. One picture is worth more than 10,000 words, and one picture is worth more than 10,000 words. What is digital image? A digital image is a representation of two-dimensional image as a finite set of digital values called picture elements or pixels. A digital image is a representation of two-dimensional image. It has a two-dimensional image and a finite set of digital values and having some picture elements, or it's named as pixels. What is digital image? Pixel values typically represent gray levels, colors, heights, and opacities. That is, pixel values just represent some gray levels, colors, and heights and opacities. Digitization implies that a digital image is an approximation of a real scene. Here, a digital image is the approximation of a real scene. Here, one picture is there. There is a deer picture, and the next one is how the picture is converted. That is pixels. Here, see the image with deer and the pixel representation. What is digital image? And common image formats include one sample per point, that is be black and white or grayscale. 3 samples per point, red, green and blue. 4 samples per point, red, green, blue and alpha, that is opacity. And the first one is black and white, and the second one is red, green and blue, and the third one is red, green, blue and alpha, that is opacity. For the most of this course, we will focus on grayscale images. What is digital image processing? Digital image processing focuses on two major tasks. The first one is improvement of pictorial information for human interpretation, and the next one is processing of image data for storage, transmission and representation for autonomous machine perception. If just we want to improve any pictorial information or for human interpretation, we go for this digital image processing. And for any image data for storage, transmission and representation for autonomous machine perception, we are going for this digital image processing. And what is DIM? The continuum from image processing to computer vision can be broken up into low, mid and high level process. And we are going to divide into 3 types and 3 processes. The first one is low, mid and high level process. Low level process. What is low level process? Here, input is image and the output is image. For example, here the example is only you are going to do noise removal or image sharpening. In low level process, only you are going to have some input image and you are going to have the same output image. Only the process done here is noise removal and noise sharpening. And the second process is mid-level process. Here the mid-level process is input image and the output is attributes. Here the process is you are going to recognize some object or you are going to segment the particular part of the image. That is the mid-level process. Any recognition, object recognition or any segmentation done in the image is called the mid-level process. And the third one is high-level process. High-level process. Here the input is attributes and the output is understanding. Here you are going to have scene understanding or autonomous navigation. In navigation, you are going to use this high-level process. In this course, we will stop that from high-level process. Here, you are going to have the low-level and mid-level image processing techniques and before high-level process also, we are going to use the same processing techniques. History of digital image processing. Early 1920s, one of the first applications of digital imaging was in the news, that is paper industries. The Barclay cable picture transmission service. Here, images were transferred by submarine cable between London and New York. Pictures here, how they are transferred means pictures were coded for cable transfer and reconstructed at the receiving end on a telegraph window. Here you are going to you are going to transfer some images by a submarine cable between London and New York. This is the first application of digital image processing. Here the image was transferred through the cable transfer where the picture were coded and for cable transfer and it reconstructed the receiving end and a telegraph window you're going to receive the same picture. This is the first digital image processing. And the next one is mid to late 1920s. Improvements to the battling system resulted in higher quality images. That is, new reproduction process based on photographic techniques. The increased number of tones in reproduced image. Just you are going to use some increased number of tones. So you, at the receiver end, you are going to get some improved digital image. For that, you are going to have your 15-ton digital image. And here the reproduction process based on photographic techniques. This is at the time of 1920s. And the next one is 1960s. Improvements in computing technology and the onset of the space race led to surge of work in digital image processing. Here you are going to have the picture as a picture of the moon taken by the Ranger 7 probe minutes before landing. At the time of 1964, you are having the picture of moon using Ranger 7 probe before the landing of space. They taken the photo of the moon, and here computers used to improve the quality of image of the moon taken by the Ranger 7 probe. In 1964, they are using this digital image processing technique. They have taken one moon photo just before landing. They have taken the photo, but by using the digital image processing techniques, they are going to improve the quality of the image and just they are successful in that just quality improvement. Such techniques were used in other space missions including the Apollo landings. And the next one, in 1970s, digital image processing begins to be used in medical application. And the next version of digital image processing in medical applications. In 1975, Sir Godfrey N. Hounsfield and Professor Alan M. Carmack shared the Nobel Prize in Medicine for the invention of tomography. The technology became computerized axial tomography scans, that is CAT scans. This is the picture of typical head slice CAT image. They have implemented this digital image processing in medical field. In medical field, for scan technology, they are going to implement this digital image processing. And in computerized axial tomographic CAT scans, they are having this image as a head slice CAT image. And the next one, in 1980s, the use of digital image processing techniques has exploded and they are now used for all kinds of tasks in all kinds of areas. These are some of the areas. The first one is image enhancement and image restoration. Here you are going to have the enhanced image and you are going to restore the particular image. The next one is artistic effects. In movies or something, we are going to have some artistic effects. The third one is medical visualization. For scan purpose, we are going to use this medical visualization. The next one is industrial inspection. The next one, law enforcement. For just we are going to have some fingerprint or some just number plate purpose. We are going to have some law enforcement. We are going to use in after 1980s. The next one, we are going to have some human computer interface. And these are some of the techniques we are going to have, some of the explored area we are going to use this image processing techniques. These are some of the examples of image enhancement. One of the most common uses of DIP techniques, that is digital image processing techniques, improve quality, remove noise. The first one is this image of an X-ray. Here you are going to have the image quality just better than the first image. This we are going to remove the noise, even you are going to get the image processing. And the next one is just industrial oriented picture is here, image is here. You're going to have the image enhancement and you're going to obtain the quality, improve quality of the image. And the third one is you're going to have some just navigation for navigation purpose, and you're going to have some just maps. Some Google Map is here, and for the images, this first one is with noise, and the second one is improve quality plus remove noises here. And the next one is, the next example is Hubble telescope. Launched in 1990, the Hubble telescope can take images of very distant objects. However, an incorrect mirror made many of Hubble's images useless, and image processing techniques were used to fix this. Here, the Hubble telescope is used to take an images of just a particular just images, And here what happened is this Hubble telescope takes some of the images as a useless one. So by using this image processing techniques, they are going to fix this and going to have the improved quality of the image. And the next one in artistic effects. Artistic effects are used to make images more visually appealing, to add special effect and to make composite images. In movie or in drama, they are using this artistic effects as an image digital just using this digital image processing, having this some artistic effects, and they are having a better quality of the movie or better quality of the drama parts. And in examples in medicine, how they are using this image processing techniques in medical field. Take slice from MRI scan of canine heart and find boundaries between types of tissues. They are going to get some MRI image of, this is an example of a dog heart. Here this is the original MRI image. If you want to find some of the detection, any edge detection, or you are going to segment things, we are using this image processing technique. This is the image of a dog heart. This is the image of dog heart, and using this image, just using some just edge detection techniques of image processing, you are going to get the particular image of the heart. Image with grayscale levels represent tissue density. Use a suitable filter to highlight the edges. You are having some filters to highlight the edges of the dog heart. And the next one in GIS, Geographic Information System. Digital image processing techniques are used extensively to manipulate the satellite imagery. Here you are going to have some terrain classification or for meteorology purpose. In GIS, Geographic Information Systems, the digital image processing techniques were well used. And the next one, the same nighttime lights of the world data set. You're going to collect some nighttime lights. Here you're going to have the lights of the world data set and global inventory of a human settlement. Not hard to imagine the kind of analysis that may be done using this data. Here you're going to have the better image quality and improved quality just using this digital image processing. And in example of industrial inspection, we are having some different area of explored area, and this is the industrial inspection. Human operators are expensive, slow and unreliable. Make machines to do job instead. Industrial vision systems are used in all kinds of industries, and we have to trust them because if we have there is no manpower and there is some unreliability by using the manpower, we can have this digital image processing techniques for fixing these industrial inspections. And the next one is PCB inspection, just a printed circuit board inspection. Here, whenever the manpower is just having some unreliable, unreliable sources, at the time we have this image processing technique in PCB inspection. Machine inspection is used to determine that all components are present and that all solder joints are acceptable. Both conventional imaging and X-ray imaging are used. And in law enforcement, this is the another area where digital image processing are used. For image processing techniques are used extensively by law enforcers. Number plate recognition for speed cameras are automated to all systems. Fingerprint recognition, enhancement of CCTV images. After 1990s, the enhancement of CCTV images is all possible in all over area, and this digital image processing techniques are used in this enhancement of CCTV image. So in law enforcement, this image processing techniques were well used. And the next one, HCL. Just try to make human computer interface more natural. That is face recognition, gesture recognition. This is all over now is possible. We are having this face recognition mobile itself and has gesture recognition. If you are having some movement of hand or something, that is called gesture recognition. And we are using this gesture recognition in all over the world. And this is the advanced human computer interface more natural with the digital image processing techniques. Does anyone remember the user interface in Minority Report? These tasks can be extremely difficult, and this gesture recognition are well overused in all over the world. Just this is the human computer interface. And the next one, the basic. Just we are going to know about some of the basic color fundamentals. And what are the color fundamentals? We are having the gray or black and white, and we are having just red, green, blue. This is RGB. Chromatic light spans the electromagnetic spectrum from approximately 400 to 700 nanometer. As we mentioned before, human color vision is achieved through only 6 to 7 million cones in each eye. Here, for 300, they are having the ultraviolet, and from visible spectrum, That is red, green, and blue. Just we have the wavelength nanometers as visible spectrum from 400 to 700, and for infrared 1000 to 1500. We are having the ultraviolet as gamma and X-rays for UV rays, and infrared for infrared. And what are the imaging types? Yeah, what are the types we have in this? What are the imaging types? The first one is gamma ray image, where it will be used. And the gamma ray image will be used in nuclear medicine. And the next one is X-ray imaging, that is for diagnosing purpose in the medical field. And the next one is imaging in ultraviolet band, that is industrial inspection, astronomical observation. Next one, imaging in visible and infrared band. The next one, imaging in microwave band. The dominant application for imaging in the microwave band is wave. Here you are going to have the wave. The unique feature of imaging radar is its ability to collect data over virtually any region at any time, regardless of weather or ambient lighting condition. Imaging in radio band, imaging modalities using non-EMI spectrum. Here, this is the gamma rays, X-rays, ultraviolet visible, next infrared, microwaves and radio waves. These are the electromagnetic spectrum arranged according to energy per photon. And what are the next? We are going to see about the fundamental step in digital image processing. What are the fundamental steps and how we are going to study this chapter? Please. The first chapter, just we are going to first what we are going to see. First, just the introduction of image processing, and the next one is image acquisition, and the next one is what is acquisition. We are going to have some pre-processing steps in image acquisition, and the image acquisition is nothing but we are going to have image pre-processing. And the next one, image filtering and enhancement. Here, you're going to have the enhancement of image. You're going to have better quality, and you're going to have the noise removal example. The next one is image restoration. We are going to remove some, or you're going to have restore some image from the particular image. And the next one is in color image processing. If you need some red, green, blue, just RGB, or you have, if you need, means just we're having this color image processing. And the next one is wavelets and multi-resolution processing. Here you're going to have wavelet resolution using some multi-resolution. Next you have compression, and compression is nothing but you're going to compress the image. You're going to minimize the size of the image. And the next for morphological processing. Here we are having some law enforcement techniques, that is for fingerprint like that. We are using this morphological process. Next one, segmentation. It is an example. If you go into segment some of the brain tumor image, and just you are going to have the scan of some brain. If you want to segment the particular brain tumor of the brain, just you're going to use this segmentation. And the next one is representation and description. You're going to represent in just a representation means you're going to represent in mathematical representation, or you're going to describe. The last one is object recognition. Here you're going to recognize any of the object, or you're going to recognize your face or gesture recognition. These are some of the basic components, just basic fundamental steps of digital image processing. Here, methods having input and output as images, methods having image as input and attributes as output. This is depicted in diagram. There is the first one is a low level process, and the second one is the mid level process. Diagram doesn't imply that all process are applied to all image, but just anyone can apply it for a specific purpose. And this is the key stages in digital image processing. What are the key stages? These are the key stages, and we are studying about that. Just we are going to, just before we studied about the fundamental step, and these are the key stages in digital image processing. If first we have to just fix the problem. What is the problem domain? Whether just we are used in medical field, or in your any other field, law enforcement, or any other industrial inspection, or any other morphological process. First we have to fix that domain. First one is problem domain, and from the problem domain, first we are going to have the image acquisition as the first stage. In this image acquisition, you're going to get the particular input image, and for that image you are going to do the pre-processing. This pre-processing step will be done in this image acquisition, and you're going to have any you're going to have for that image, what is the image in level, or the unit 2 scale or 3 scale. Just some pre-processing will be done in this image acquisition. And the second step is image enhancement. What is image enhancement? Image enhancement is nothing but you're going to have some just enhancement. You're going to improve the quality of the image. Or the second one is you're going to remove the noise of the image. Just the basic step. You're going to improve the quality, or you're going to remove the noise. Some image enhancement will be done in the second stage. What is the third stage? Image restoration. For example, if you have any image which was taken in moon or any space images, in that image you're going to restore some of the part, and from that just can use this image restoration. By using this image restoration techniques, we can restore some of the image from the just original image. You can restore some of the image. That is the image restoration. We are having some filters or some having techniques in this image restoration process. And the next one is morphological process. For example, if you're going to have some fingerprint, you're going to open one particular door by using the fingerprint, and that will become by under this morphological process. And this morphological process, we are going to have the particular just recognition or some morphological techniques we are going to use this morphological processing. And the next one is segmentation. What is segmentation? If you're going to detect some brain tumor or some liver cancer, what we will do? Just we can take the particular liver scan image, and you're going to just use this segmentation techniques, and just you're going to find in liver particular which is the area where the liver cancer occurred. So by using this segmentation techniques, you can identify where the liver cancer is there. Just you're going to segment the liver cancer area by using this segmentation. We use in lot of medical field and some of the industrial field also we can use. And the next one is object recognition. What is object recognition? Object recognition is nothing but you're going to recognize particular object. For example, we can use just you can have some just you're going to recognize the high speed cars. With the car which is in just in the road, we having just above the speed above 80 kilometer. You're going to recognize by using this visual image processing techniques. You can fix the just which car will be in above the speed of 80 kilometer. By using this object recognition techniques, you can fix the particular image of the car, which will be in the this which will be the just overcome the rules of the particular law, just particularly they having in the road safety. If they have the rule as we will go only by just 70 kilometer speed. If any other car, they will be moved by 80 kilometer. By using this visual image processing technique, object recognition, that car will be taken an image that will be as using this object recognition, and this object recognition, whichever car they will be having above 80 kilometer, this by using this technique we will capture that. And this object recognition will be used in law enforcement also. If you want to somehow face recognition, if you have this, if you are just for example, if you are lock and security purpose, you have the digital lock. For example, you are having your locker in your home or in your bank, just use this face lock. If you have this just lock this face, just it will recognize your face, then it will open. Just for that you are having this object, using this object recognition, you can use your face as a recognition, and you can lock safety lock up for law enforcement purpose. We can use this object recognition digital techniques. And the next one is representation and description. If you want to represent your image in a 2D transform form or a Fourier transform form, you can use this representation and description. And the next one is, if you have you are doing your find your problem domain, and you have all the key steps, and you're going to save the image in a compression form, or you're going to send the image in a digital just image compression form, you can use this image compression. Using this image compression, you can have some image as a compressed form, and you can send. And the color image process is nothing but you can use this red, green, blue or GB and opacity as a color image processing techniques if you want to improve the particular image of the color, or if you want to, for example, if you have the grayscale image and if you want to use this color image, means you can use this technique. Or if you have the image, one particular image, if you want the improve of a particular color, for example red, green or blue, if you want the green color, means you can have the green color filter. Using green color filter, you can enhance the green color filter. Your image, you want the image with a greenish color, you are just a greenish black one, you're using this color image processing techniques. These are some of the key stages in digital image processing. And the next one, just this is the example of image acquisition, how the image acquisition is there. Just first one is the image Here using this imaging system, how we are going this, you are going to have the pre-processing, you're going to have the digital image as a pixels one. You're going to convert the image as a pixels one. If your images will be in analog form means this in pre-processing step, you can convert this image into digital form. That is a pre-processing will be done in this image acquisition. This is the example of image acquisition. And the next one, image enhancement. See the picture. Here the picture, the first one is the original picture and the second one is image enhancement. How the image enhancement is done here. Here the first image is the quality, just quality with a low level. And see the next image is the improved quality. Here the image, using this image enhancement, you can have the better quality of the particular image. And the next one is image restoration. See, this is some of the image taken on this space like that. Here, how they restore the particular image. This is the original image, and in the next image they have the improved quality, just restoring the original image. That is the image restoration. What is, see that this is a morphological process. Here you are going to calculate the fingerprint, and how we are just using this morphological process. If you are going to analyze the same finger for particular, just you are going to have you're going to analyze the image processing of two fingerprints, two persons. You can take the different persons fingerprint and using this morphological analysis, just how it will be morphologically, matrixally, how it will be calculated. You can analyze that, and then you can concluded that what is the just fingerprint of a first person and what is the fingerprint of the second person. Here, just how the morphological process is done is shown here. And the next one is the segmentation. This is the segmentation. If you want to segment the particular one, for example, here you're going to segment where will be segment at the low level, or where just if you want to analyze where it will be high level. At the segmentation, you have to segment into a different point. And the next one is face object recognition. If you here, you're going to have the eye recognition. Where is eye viginica, eye vesicle, eye sedosa? How do object recognition? How it will be recognized? And the next one is representation and description. Here you're going to represent using some Fourier transform forms or some matrix form. Here how the pixel is calculated, how the images is there. Particular images will be converted to the pixel, and for the pixel you are going to do this image representation and description. And the next one is image compression. See here, you are going to convert the compress your image into some just compressed form. You're going to compress, you're going to have the just reduced memory file. That is the image compression. And the next one is color image processing. That is the first one is the image. If you want to have some color image, what is color image processing? That is, you're going to add some red, green, and blue image. If you enhance your image with this color image processing, you can obtain using this color image processing. Thank you.